Imagine it's the middle of summer. The sun has been beating down on your house all day. Outside, the pavement feels hot enough to cook an egg. Your phone says it's over 100 degrees, and the air feels heavy every time you step outside. You rush back inside, turn on your air conditioner, and hope your electricity bill doesn't make you regret it next month. For most of us, that's just normal life. We've been taught that if you want to stay cool, you need expensive technology. Bigger air conditioners, more powerful fans, better insulation, smart thermostats, higher electricity bills. But have you ever stopped and asked yourself one simple question? How did people survive thousands of years before electricity even existed? Think about it. Ancient civilizations lived in deserts where summer temperatures regularly climbed above 100 degrees. They didn't have air conditioners. They relied on innovative natural methods to beat the heat. They built homes where people could sleep comfortably, store food longer, and escape the brutal summer sun. How did they do it? That's the mystery we're going to uncover today. And what's fascinating is that some of those ancient cooling principles still work today. No, I'm not saying you'll throw away your air conditioner tomorrow, but understanding the true secret to cooling isn't about just creating cold air. It's about removing heat. This simple change in perspective will make you see your home, your windows, and even the summer breeze in a completely different way. Cooling happens around us naturally, every day. When sweat evaporates from your skin, you feel cooler. When you step out of a swimming pool and a breeze hits your body, you start shivering, even on a warm afternoon. When rain falls after an extremely hot day, the air feels fresher. These aren't coincidences. They're demonstrations of nature's cooling wonders. Ancient builders worked with nature, not against it. Instead of relying solely on trapping air inside, they embraced natural flows. And that's what we're going to explore today. Throughout history, the most ingenious ideas often aren't the newest ones. Instead of relying on machines, people turned to physics to solve their problems. This tale is astonishing because many ancient civilizations shared similar cooling techniques despite never having met. From ancient Persia to North Africa, the Middle East, traditional Asian villages, and rural communities living with limited technology, many cultures found that moving air and controlled evaporation greatly improved comfort in hot weather. As I researched traditional architecture globally, I was captivated. How could societies, oceans apart, discover nearly identical solutions? Was it mere coincidence? Or did they observe nature more keenly than we do today? The more I delved, the more extraordinary the story became. I uncovered towers that caught wind from every direction, underground rooms naturally staying cool in scorching heat, and clay jars that chilled water without electricity. Each solution shared one trait. It leveraged the natural movement of heat instead of costly technology. Many modern homes have lost this wisdom, often built first and then remedied at a high cost. Ancient builders asked, how can heat be prevented from becoming a problem? They understood that by using porous materials and water in an airflow path, the gradual evaporation could absorb heat from the air. A timeless science, varied in material, unified in principle. Have you ever wondered why a breeze can feel so refreshing on a hot day? It's because of evaporative cooling, a natural process that makes the surrounding air feel cooler. It's the same reason why sweating helps regulate your body's temperature. It's simple, it's natural, and it's all about physics. But here's a crucial point that many online videos neglect. This isn't magic, nor a substitute for modern air conditioning. Its effectiveness is shaped by various elements such as airflow, humidity, and strategic placement of the setup. In arid regions, evaporative cooling can be impressively effective. Conversely, in humid areas, its impact is minimal since the air is already laden with moisture. Grasping these limitations is as critical as understanding the advantages. Real knowledge isn't about accepting every claim. It's about understanding why something works, when it works, and when it doesn't. In this video, we will explore how ancient civilizations harness these natural cooling principles. I'll explain the science in straightforward terms and demonstrate how to create a simple DIY version of this system. Our aim isn't to promise miracles, but to appreciate one of history's oldest cooling techniques and uncover the lessons it can teach us today. Cooling simply means removing heat from one place and transferring it somewhere else. That's exactly what every air conditioner does. It doesn't create cold air out of nothing. Instead, it removes heat from inside your home and releases it outside. Now here's where nature gets incredibly clever. It already has a built-in system for removing heat called evaporation. Imagine a hot summer afternoon. You're sweating, feeling uncomfortable, until a breeze sweeps across your skin. Instantly you feel cooler. Did the wind turn cold? Not really. The breeze helps your sweat evaporate, and with each drop that vanishes, a bit of your body's heat goes with it. Essentially, your body acts like a natural air conditioner. This principle is common in nature. When rainwater evaporates from the ground or when morning dew disappears with the sunrise, heat is absorbed. Evaporation requires energy, which water borrows from its surroundings, effectively stealing heat. Now, if we increase the surface for evaporation, such as using porous materials like clay or charcoal, this process becomes more efficient. But remember, while activated charcoal is porous and aids in evaporation, it doesn't produce cold air itself. Its magic lies in holding moisture for evaporation and in absorbing impurities. So if anyone claims charcoal cools by itself, that's not quite the story. Let's talk about a hidden hero in our everyday life: evaporation. It's the unseen force working tirelessly to cool us down, with a little help from charcoal. Imagine charcoal as a sponge. It doesn't produce water, rather it holds it in a beneficial way. Porous materials like charcoal help spread moisture across vast areas of their surfaces, allowing the moving air to evaporate this water efficiently. The airflow is the catalyst here. Without it, evaporation significantly slows down. Think about drying clothes in a closed room. Eventually they'll dry, but it takes ages. Once outside on a breezy day, the same clothes dry much faster. The difference? Airflow. This principle is why ancient builders valued directing wind through their homes. They didn't have electricity or motors. Instead, they harnessed the power of natural physics. In dry regions like Arizona or Central Australia, evaporation happens swiftly due to the dry air's eagerness for moisture, resulting in noticeable cooling. Meanwhile, humid areas see slower evaporation. Also, activated charcoal plays another role, adsorbing odors, making it a common component in purifiers. This dual functionality of cooling and freshening the air illustrates the marvel of nature's simple yet effective designs. Now that you understand the science behind evaporative cooling, here's the question that amazed me the most. If this principle is so simple, why don't we see it everywhere today? To answer that, we need to travel back nearly 3,000 years to one of the hottest places on Earth. Imagine standing in the middle of a desert. The afternoon sun is relentless. The ground is so hot that every step feels like walking across a giant oven. There are no trees providing shade, no air conditioners humming in the background, and certainly no electric fans. Yet people didn't just survive here. They built thriving cities, raised families, stored food, ran businesses, and lived comfortably in temperatures that would make many modern homes unbearable without air conditioning. One of the greatest examples of this incredible engineering can still be found in the ancient city of Yazd, Iran. Even today, visitors are amazed by the tall towers rising above the rooftops. At first glance, they look like old chimneys. But they aren't chimneys at all. They're called windcatchers, or badgers, and they represent one of the smartest cooling inventions ever created. These towers were designed to capture even the slightest breeze. Instead of letting the wind simply pass over the building, the tower directed it downward into the living spaces below. Think of it as nature's own ventilation system. No motors, no electricity, just carefully designed architecture working with the wind instead of against it. Today, we're exploring the benefits of passive cooling in your home. Instead of relying on air conditioning to drop temperatures artificially, passive cooling methods help reduce heat naturally. They improve airflow and create a more comfortable environment, especially in dry climates. Think of it as giving nature a helping hand. If your room already has good airflow, This method can make that airflow feel cooler and fresher. However, if your room is completely sealed with no ventilation, even the best passive cooling system won't perform well. Understanding that difference is key to success. The beauty of this project lies in its simplicity. You don't need expensive tools or technical skills to get started. Most items are inexpensive and easy to find. Here's a basic list of what you'll need: a shallow tray, activated charcoal granules, clean water, and an unglazed terracotta pot. No wiring, drilling, or complicated installation is required. The system can be assembled in less than 20 minutes. It's about improving airflow. Even a gentle breeze makes a difference, and placing a fan to assist this process can enhance efficiency, consuming far less energy than conventional air conditioning. Embrace passive cooling and let nature take the lead in creating a cooler living space. In today's session, we're diving into the ease and importance of maintaining your passive evaporative cooling system. Regular maintenance ensures a long-lasting, efficient system. Each day, make sure the charcoal remains damp. If it starts to dry, simply add a bit of water, but remember not to saturate it. Every few weeks, ensure you rinse the tray to keep it free from dust and debris. Replace activated charcoal periodically to maintain impeccable cleanliness and odor control. This system thrives in dry climates, low humidity zones, shaded areas, and rooms with steady airflow. However, it's less effective in high humidity regions as the air is already saturated with moisture, slowing evaporation and cooling. Beyond the temperature drop, enhancements in air quality, reduced stuffiness, and fewer odors create a comfortable atmosphere. Avoid expecting these systems to perform like traditional air conditioners. They require airflow for efficiency and use specific activated charcoal rather than barbecue charcoal. Consider your local climate for optimal results. Ultimately, learning from ancient cooling methods highlights the simplicity and harmony of working with nature for comfort in our homes. But here's something even more interesting. Passive cooling wasn't the only secret they mastered. They also discovered ways to store cold temperatures, preserve food without electricity, and build comfortable underground spaces all year long. Some techniques are still used today, and modern architects are studying these ancient ideas again. After all we've explored, let's revisit the question: why did ancient civilizations focus on nature instead of fighting it? The answer is simple. Nature doesn't send an electricity bill. For millennia, people designed homes to blend with their environment. They observed wind directions, sun paths, and naturally cool materials. Instead of relying solely on machines, they trusted observation. Fast forward to today. Modern technology like air conditioning ensures immense comfort and saves lives in heat waves, making it one of humanity's greatest achievements. Yet, many overlook natural home heat management. Instead of wondering about designs, we focus on air conditioner power. Imagine two houses. One harnesses breezes and shade, the other heavily relies on its AC. The better designed home requires less energy. Solving the issue before electricity is needed is a principle still teachable by ancient builders. Technology supports good design. It shouldn't replace it. From strategic tree planting to clever window coverings, many inexpensive practical ideas exist. Passive cooling isn't a modern replacement, but a partner to achieve comfort. Now let's return to the DIY system we discussed earlier. Will a tray of damp, porous material transform your home into an ice-cold environment? No. Anyone promising that is setting unrealistic expectations. But could it contribute to better airflow, localized evaporative cooling under the right conditions, and a more comfortable space, especially in dry climates? Yes, that's a much more realistic way to think about it. Science isn't about miracles. Science is about understanding how natural processes work and using them wisely. The same principle applies to activated charcoal. Many people believe it's the secret ingredient. In reality, the real hero is still evaporation. Activated charcoal simply provides a large porous surface and can also help reduce certain odors because of its absorptive properties. The cooling comes from the water changing into vapor. That's an important distinction. When we understand why something works, we're less likely to fall for exaggerated claims online. And that's exactly the mindset every curious person should develop. Don't ask, does this work? Ask, why does it work? Those two questions lead to completely different levels of understanding. Before we finish, I'd like to leave you with a small challenge. The next time you walk into an old building or a traditional village home, don't just admire its beauty. Feel the air, notice where the breeze comes from, look at the thickness of the walls, and pay attention to the position of the windows. Ask yourself, why was this built this way? You might discover that the greatest engineering lesson isn't hidden inside a modern laboratory. It may have been quietly standing in front of us for hundreds or even thousands of years. If you enjoyed learning about these forgotten engineering ideas, let me know your thoughts.